Didn't. So it worked really well for the apical side, but not so well for the basal. That's because I made a mistake here. The basal with FSM should be low and not high. Let me try it again. You guys got this? It's everything's perfect. So I probably made a mistake. No. Okay, so what did I did wrong? Maybe here. No. Said by him. Okay, one thing that I can try to do, you probably want these things to be a little bit longer, right? So probably can make the cell target volume for the core to still be 64 8 by 8. In this case, we'll force the cells to increase. So let's try to do this. Now it's beautiful. I think that I cut too much of the core cell, and eventually, for some cells is missed. And because we want more cells to be long, what I just made is I made the target volume of my core cell to be still 8 by 8. So it's still more or less squarish, plus the top and bottom compartments, and then I get this kind of, the cells automatically elongate. And they stay more or less stable. And I think this green that I chose here is not really great to see the apical. I'll choose a darker one. I think that's a little bit better to appreciate where everything is. So now I made you guys do a lot of work to draw these boundaries, but the truth is, if you get a target volume for them and you specify the correct energies that you give them to be stable, that you could have drawn these compartments anywhere you want, and they automatically sort out to the correct place because of the energies. So you didn't need to bother doing this thing. If you put it anywhere, even a single pixel would still work. You can try this. Yeah, it would take a little bit of some time to go there, but because it's so far away from its target volume, it would work. So I'll comment. I can comment this line and this line, and do a random positioning of the so I just put in a very small places and then stop. So see, it just points there, right? And if, okay, it was too small for this to work. Because this is also under pressure to grow. So that's why it did not work very well. But if okay, it didn't work very well, so you do not believe me, probably. Ah, because I make the volume exactly equal to what it is. Okay. So the volume I want to be about 16, right? Okay, now it should work. No, it didn't work very well. To be strong, well, not very great. Okay. Well, okay, it didn't really work, my demonstration, but well, we already have epithelium working, so let's go back to what we had before. So is this working for everybody? So what you can try to do now is add, now I can finally go back to try to make our folding and try to make it make a furrow by apical constriction, right? So to do this, we have to go back to our epithelium XML and play again with the FPP links. So the apical site here is on top. You want to probably add apical links between all the apical neighbors, and then have to be some value in a given time simulation, make all those cells that are within a range to have increased strength of this apical links to either diminish its target length or increase its lambda volume, and then have the whole thing constrict. So to do this, so basically what you want to do is replicate this movie, right? Stop this. So here in the focal point plasticity, we want to untag the local one. We want to be able to modify it from the Python code. And what we want is add links between the apical site of the cells. So I have to look here for apical to apical, this one, and uncomment. Okay. And you probably want the maximum target distance to be 8 to begin with, which is about the size of the cell in its width. And the maximum number of junctions to be 2. So one neighbor to the left, one neighbor to the right. So we save this and now run the simulation. The links should appear automatically. Actually, something wrong here. I comment this. That's why. Okay. Do you all get this? So I accidentally comment something here. That's why it was error in my simulation. But here I make it very easy to create those links. So make activation energy to be minus 10,000, target distance 8, and maximum number of junctions 2. So now every apical side of the cell is linked by FP link, which is orange here in my screen, which is not great for you guys to see. So I'll make a different color. So now I have those links here, and what we may want to do, what we also may want to do is add links between the internal compartments of the cells to enforce the height of those cells. So for this one, we have to go to the internal parameters and make a link between basal and core and apical, core and basal. But you may also would like to make a link between the apical and the basal. It's just that in this case you make so you have your cell here. You have the basal side here. You have the apical side here. And this is the core side. And you have a center of mass, a center of mass, a center of mass. The link works on the center of mass, so you probably want to make it a little bit more stiff. You add a link here, right? So that will make those two distances the same. But this cell can still be very happy. Oops. Having this kind of configuration because this distance here is to be obeyed. Okay, so if you want to prevent the cell from bending, what you can do is you can add a new link direct from the basal to the apical, which double the length of those two links, or with the length equals to the length of this plus this. This way, this will not be, because this is going to be too short, so that you straight up your cell to be this shape. Make sense? So you probably want for your internal parameters to make so that to be more or less the microtubule cytoskeleton of the cell. You want probably to do this so to prevent the bending, to add a penalty to it's not make easy to bend the cell. Just parameters. Then you'll not be linking the internal cells. You'll be linking this to this. That will be the problem. Right? Exactly. Once you define that this will be the internal compartment of your cell, and then you use the internal links, then you only do between the domains that belong to have the same cluster ID. Yeah. Yeah, because the cell may have two repeated domains inside it. Okay. Or if you make a link between the core and the apical, this apical side probably touches this core and also the neighboring cores. So then you make 3 links, right? If you don't transfer internal parameters. So, but that's always you have to specify is internal or external, right? So let's make this as well. So here you want to uncomment basal to apical. We can delete the other things that we will not use, like core to ECM, basal to ECM, apical to apical, Apical to ECM we don't want, ECM to ECM we don't want. I'll just delete this to make the code cleaner. Core to apical we want. Core to basal we do want, internal. So these are the 3 internal ones that we want, right? So let's look at, let's make the activation energy to be very low, so it's more likely to make those links. Now, what should be the target volume? Let's look here. Stop simulation. So now I have to count, more or less count pixels. So the X center of mass will be more or less here. So that would be 1, 2, 3, 4, 5 more or less. One side, 5 the other side, and 10 all across. So core to base will be 5, core to apical will be 5, and basal to apical will be more or less 10. We can also use this to actually make the cells a little bit longer, right? Or a little bit shorter. Of course, you have the problem that the whole thing is in periodic boundary condition, so you cannot make too long because there's not enough cells to do it. But let's choose the approximate numbers. So is everybody following this? So we uncomment these 3 internal parameters, core, basal, core, apical, and basal to apical, to make those 3 links that I draw here. And I make those 2 here to be 5. This is 5, this is 5, and this is 10. If you make, for some reason, your basal side or apical side to be bigger, you probably have difference in those 2 lengths here. But for the penalty on bending to work, this length here had to be the sum of those 2, right? So if you do this, did it work for your computers? Yes? Did it work in yours? They're running, okay. I'll run on mine and see if it works. Don't forget to save. So if there's a red thing here, it's because you did not save. And then you have to stop simulation, hit play, and then do I see the internal links? Some of them, let's see. Yes. So here, okay. I only seen 2 links and not all the 3. Why? Do you know why? They don't begin in contact. Yes, exactly. Because these links that the code does itself, you only do if they are actually in contact. They have to be in contact, have this neighboring order here. I can change the number to be huge, but I don't know how far I can do to make it work. But what would be another solution to make this work? Neighbor order, but another one. Force it. Yeah, because we already have the loop here on the steppables, where we know the identity of the cell, so we can just make this link, right? So why don't we do this? Let's just make a link between apical and basal. All the 3? Oh, okay. So, well, I don't know why it works for you. No. No, you're missing the direct link between the apical and the basal.
Oh, I'm going through the center, through the core?
No, because this is core apical, core basal, but there's not a direct link between the green and the red. And you want that because you want to prevent the bending of the cells. You do have all the 3? Yes, you do have all the 3. Why?
I don't know. What you told me.
But how you draw those compartments? Maybe you already start them to touch each other. Okay, anyway, yours working, so let's just add by hand here for everybody that's not that lucky. So how do you draw? Do you remember how you make an FPP link? You have to go compensatory Python, focal point plasticity, create FP. Okay, now which option should I choose? Within cluster, yes. Because you want to make an internal one and not an external one. So base that, self focal point plasticity, create internal focal point plasticity between which cell? Should be the apical and basal. Now, it's, of course, if you write basal and apical, the result will be exactly the same. There is no polarity in those links. Now, lambda, you want to be exactly the one that choose an XML. So probably we use 10. So let's use 10 here as well. Okay, 10. Target distance. That should be 10 because the other two were 5. So let's make 10 here. And maximum, okay, I'm doing these things. That's not the right way to do. The right way is to write all these parameters before. Here. This way your code is more readable. The lambda is 10, the target distance is 10, and the maximum distance is, we set to be 20. This way is more, if you just put the numbers there, you don't remember exactly what those numbers mean, but this way you know what those numbers means. Okay. So sometimes it's better to spend more lines in code to make your code more legible than to just type numbers right there. And see that the comment here now has the word internal in it to say that is between two internal compartments. So if I save this now and I run the simulation, yeah. Now I see the three links in all the cells. Okay. Make sense? Okay. Now, what we want to do, and I'll leave you guys to you do this, you want to specify a region here in the simulation, more or less in the middle, where you're going to go all the cells, and all the cells that are in the region, I want to decrease the target length between the apical and apical compartments to force some kind of constriction of those cells and see if you can actually get a furrow to form. You'll not get full invagination because you probably have to run into an issue that you don't have much cells to draw from the sides, but at least you can get some kind of deformation of furrow. Okay. So ideally you have to wait a few Monte Carlo steps. Let's wait 200 Monte Carlo steps, and then you do this increase in strain. And then you can make either gradual or all of a sudden. You choose. Do it. Yeah. Yes. Oh, okay. So I see an effect here, but I didn't really get a furrow, right? But you see that I changed the properties of the apical links.
So what you did is you're deleting.
No, I didn't delete anything. I just changed the properties.
So every time you go in and create a new link,
Yeah,
that overwrites the old.
it overwrites the old one. Yes.
But the principle you did, you mentioned delete links, and there's a range, right?
Yeah, then I have to delete it and create a new one. Exactly. So one thing that I can also try to do is, instead of have those apical base compartments to be that thin, I can make them a little bit bigger. Add more H cells to it. Which of course then I have to increase this distance to be a little bit bigger. So what I'm doing now, I'm trying to tune the simulation to see if I can get a better shape. Too much. Ah, that's my mistake. This has to be.
Yeah. And anything else is equal less than 50. So it's just one of the things that's still crash. Oh, there it is. No, actually, it works. No, because I don't think they actually got up to the step. Oh, there's it. Okay.
Ah.
So say MCS, right?
So one thing that I was not very careful is that when you get those properties, you should get the properties from the FPP within the cluster, not outside. I don't know if there's going to be a major effect, but you should set get internal focal point processing data. And what I'm doing here now is I'm doing this more continuously from Monte Carlo step 200 onwards. I'm slowly decreasing the target distance to make it smaller and smaller and smaller. But of course, I want to be bound by 0, right? I don't want to make it negative. So I can make this maximum function that returns the bigger value. It's either this one or 0. So if this becomes negative, I'll just stop at the target distance to be 0. And this is the rate at which I decrease the target distance between the cells. Yes. Yeah, it should be. Yeah, it should be the external. I'm sorry. Yes. Thanks for catching my mistake. Oops, I get an error. This error. Higher or equal to 200. Yeah, the problem with this code is that I'm changing the apical twice for every pair. So I have to have a do this only if. Yeah, now I try to do incrementally, but then now it's getting more. There's an effect that I know what's going on, but I think it's not worth continue this, or maybe it's better to wrap it now. Did you, all of you got some kind of effect? You didn't get any effect? No. At least doing all at once. Suddenly. Okay. Want to say something?